Gravitational lensing is an effect where light from a distant source traveling to an observer is bent by gravity around a massive celestial object or cluster of objects, producing one or more distorted mirages. Let's take a look at this gravitational lensing. Here we're looking at an artist's sketch of gravitational lensing. We have planet Earth over here on the left, and we have a telescope on Earth, and we are looking at, or would like to look at, this background object on the right. It's a background galaxy, and I'll label it B sub G for background galaxy. Now, Earth, we can't observe the background galaxy directly. We observe instead what are called mirages. So let's take a look at the light. Light coming from this background galaxy doesn't come straight through to the telescope. The light gets bent around a massive object. Now, it could be just a single massive object, such as a galaxy, or it could be a cluster of objects, which in this case is showing you right here that we have a cluster of objects. And so this light from the background galaxy is getting bent around this cluster of objects. The light comes into the telescope, and from our vantage point, looking backwards, we don't see the background galaxy. We see mirages. So here's a mirage, and over here's a mirage. So a gravitational lensing is an effect where light from a distant source is bent by gravity around a massive celestial object or cluster of objects, producing one or more mirages. And the mirages tend to be distorted in shape. They don't look like the original background galaxy. They have a distorted shape to it. Let's take a look at some examples. On the left, we have an image of an Einstein cross. We have quasars, 1, 2, 3, and 4. And these numbered objects are the mirage quasars. In the background is the true quasar, but we can't see it due to the foreground massive object, which is a galaxy, and the light gets bent around, so instead we see this mirages. And there are 4 of them. In this case, we're looking at a blue background galaxy. The blue background galaxy is behind this foreground galaxy. The light is getting bent around the foreground galaxy, and from our point of view, here's our telescope, we're looking back. We are looking along the edges, and what do we see? But we see these mirages, and they form this horseshoe shape around our foreground galaxy. These are called Einstein rings. You might see one ring, you might see another ring around it, and even a third ring. These are called Einstein rings. Let's look at an animation. In this animation, we're going to look at the blue light of a star. Now, the light of the star will remain circular and blue, but the light that we see from planet Earth will be the white light. The foreground galaxy is the gray object in the center. So the blue light stays the same. The white is what we see from planet Earth. We see the white light get distorted, and as the blue light passes away from the foreground object, the blue and the white object remain the same size. It's only when the background object passes behind the foreground object that the light gets distorted. Once again, white is what we see from planet Earth. We see the distortion of the light. Blue is the actual object. Let's look at another example. In this case, we're looking at a black hole. Here's a black hole, and this is going to be a galaxy that we're observing edge on. So the galaxy is going to pass behind the black hole, and you can see that the galaxy will get distorted. So here is the gravitational lensing object, is the black hole. The black hole is the one that's doing the bending of light. The background is the galaxy, and the galaxy's light is being bent around, as you can see. This effect is our gravitational lensing effect.